Good morning and welcome back. I'm going to do another Leetcode easy question today. It'll be in the style of a mock interview, so I'll be using a Google Doc because sometimes you only have access to a notepad and not a normal IDE. We'll pick one at random and I'll start the timer. All right, we're doing 2574, left and right sum differences. Let's have a look. Given a zero-indexed integer array of nums, find a zero-indexed integer array answer where the length of the answer is equal to the length of nums, and the value for each indice answer is equal to the absolute value of the sum on the left and the sum on the right of a indice in the inputs. And if there's no such element, 0. So this is actually really similar to a previous one I did, where we're keeping track of the sums on the left and the sums on the right. And it's the absolute value of that. So if it becomes negative, it becomes positive. So, okay. And return the array answer. I'll keep this over here on the left side and we'll do our answer on the right side. I'm looking at the examples right now. I'm assuming the interviewer is kind of walking me through this if this was in person. So we have input 10483. We'd expect for the first one, let's say the output sum total is the left sum minus the right sum. So the left sum of this at this index, is 0. And the sum to the right is 4 plus 8 plus 3, which is 15. And that gives us our 0 minus 15, absolute value is 15. Okay, that makes sense. And we also get an example with just a single value, which in this case, a sum to the left and a sum to the right are both 0. And so we return 0. So a question I'd have is, what happens if you get an empty array? I'd expect a false answer or like a none output. It looks like in this case, we're always going to get at least a length of 1 to 1,000. The other question is, how big could the numbers get? Would they ever overflow the integer? And in this case, the numbers are going to be safely within that integer overflow. Looks like it's 10 to the 3 is 1,000, 10,000, 100,000 maximum. So we don't have to worry about those things. Let's just start doing a answer. So immediately what I'm thinking about is iterating through the list and keeping a tally of the sums on the left and right. If we wanted to go even more straightforward, we iterate through the list, and for each index, calculate the sum, the left sum and the right sum. So this would also be a O of n operation because we'd be calculating the sum of values to the left and to the values to the right, and this would be a O of n also. So a combination of those two would be of O of n squared. So that's what at least this iterate through list calculates sum as you go. So one could ask the interviewer like, oh, could we do it this way to start? And that's valid. They might ask you to see if you can optimize it a bit. I'm already starting to think about this one right here. So this is just like the last one, where instead of calculating the full sum every single time, we keep a running tally of the sums of the left and right, and for each index we add and subtract it from the sums, and that way we're doing only O of 1 operations within the list. And so our final run through will be O of n time, and we're not storing anything. Well, we are creating a whole new list output, so we will have O of n space. And I think an important thing to know here is that not only is this a bit better than the previous one, it's also the best you could possibly do, just because we are always going to have to check every single value inside of the input array, and we're going to be creating an output array that's the same length. So you can never do better than this. There are ways to optimize within this space, but this is probably close to optimal. So let's have a go with this one right here. So let's start with a skeleton. I'd say let's call it, this is called left and right sum differences. Left, right, sums, diff. And we'll pass in the input array which is a list of ints. And we're going to be putting out a list of ints as well, which is going to be our outputs array. And what I'd like to do is keep a running tally for the left sum and a running tally for the right sum. And this actually will just sum over the whole array initially, and this will be an O of n operation once. And then we'll create a new array of zeros, the length of nums. So let's just first get the length of nums and keep that as a variable. And we'll create the output array, and we'll call this answer, it looks like, equals a set of zeros times the length of the input. Also O of n, time and space. And now we iterate over every value for, we'll keep track of the index as well as the value. And we'll use enumerate to get the index as well as the value of the num. And at each point, what we want to do is update current sums. Then we'll get index answer and insert or set. And then at the end, we're going to return answer once we're done with this. So let's say left sum. When we get to an index, we're going to be adding the previous one. Because one thing to keep in mind here is that we're not including the value in the current index. We're only getting the sum to the left of that index and the sum to the right of that index. So here, in fact, the left sum is going to be increased by whatever is in nums of I minus 1 if I is greater than 0. Because for the first one, we're not actually going to be able to do it. And then similarly for right sum, we're going to be subtracting nums of the current index. And we don't need to do any sort of if checks here because we'll always be within the array. And so for the first one, let's say we had our 15, 1, 11, and 22. When we get to the first index, initially the sum is the whole range for the right sum. So that would be, let's see, of this one. So 15 plus 10, 25. When we get to the first index, we're subtracting that first index. We take out 10, we have our 15, which is the correct right sum. And the left sum is still 0 at this point. So now we take the absolute value of left sum minus right sum, and we're going to set our answer to it at that index. And let's just confirm answer is equal to left and right sum. And that is the main loop. So let's get rid of this. Okay. So we're about 7 minutes, 50 seconds in. And I'm trying to think of any edge cases we have here. So one of the first questions had been, what happens if we had an empty array? Here, our left and right sum would be both 0. The answer would be 0 times 0 would, I guess, be an empty array at this point, and it would return an empty array at the output. If that's what they want, then we're golden. Otherwise, we could do an if check here. Similarly, we can ask what happens for a single integer. We have our sum for that value. When we get to the first integer, we subtract that. The answer is equal to the 0 minus 0, so we get a 0 output and it returns 0. So it works for a single integer, or it should at least. Are we missing any absolutes? We're making sure that it's same length. And okay. Let's do a little bit of cleanup here. Since we're only using n once, we don't need to store it as a variable anymore. We've initialized our answer. We have our O of n, and this is also O of n. These are both, all three of these are O of 1, so our final result is a time O of n space O of n solution. All right, let's try putting it into our solution here. It looks like nums is the same and output's the same. That's good. Make sure we have no tabs when we've copied it over. And left sum, right sum, answer. All right, let's have a look and see if this runs. Oh, all right, so we're not allowed to be you need to add an else statement here when you do an inline if and else. So what do we add to the sum if it's less than 0? We don't add anything to it, so we keep it 0. So let's try that again. Make sure you give proper names. Anything else going on over here? You guys may have seen that beforehand. Sorry about that. Okay, passed the test cases. Let's see how it does with the solution, with the submission. All right, and it got accepted. And don't pay too much attention to these speeds. It's important to be a little more optimal than this one, but most of the time this has to do with the backend running for simple questions or questions that aren't too algorithmically complicated. But it's still nice to be faster. Okay, well, I think that gives the general idea of how you'd approach a question like this. We can start talking a little bit more about other approaches. In the case of this one, I think the main point is that you want to keep track. You want to know that calculating the sum to the left and the right, these become O of n operations. So if you can find ways to do that inline, you'll save yourself a lot of time complexity. Anything else we can think of here? Try not to be too clever. There are ways you could do inlines for a lot of these things, and see how I even tried to do an inline for this statement right here, and it ended up kind of biting me. It's not a big deal, but being too clever doesn't really make the code more readable a lot of the time, and doesn't win that many points with the interviewer. So just try to be concise, try to be straightforward, and yeah, and just, you know, kind of talk out loud, kind of like I'm doing here, and I think you'll have a good run of it. All right, cheers, and next time.